Hey everyone, I'm Sneha, and I recently built a project, a system where I just talk to my network gear in simple language. I say something like configure OSPF, and my routers go saying, yes, ma'am. No scripts, no CLI, no YAML crying at 2 a.m. It's just LLM, AI, JSON, and some serious engineering caffeine. In this video, I will walk you through a project I've built that combines natural language, network automation, and agentic intelligence, all tied together using Model Context Protocol, which is gaining a lot of traction nowadays, which is MCP. So the MCP server configures routers, monitors, interfaces, and sends alerts, all from just plain English commands. So, what is MCP? So I like to think it as the API buffet for all AI agents, but people on the internet call it the USB-C port for AI applications. MCP is a spec that says, okay, here is how to tell an AI what tools it can use. Here is how to describe those tools, and here is how the AI should behave like a responsible adult using them. So MCP essentially bridges the gap between AI agents to other data sources or code. Basically, it is what connects intent to action. It will be clearer as I walk you through my architecture. So this is how my MCP system looks like. And here is the brain of the whole operation, the MCP architecture. Everything you see here is connected through my custom built MCP server, that black box that you see in the middle doing all the real work while I'm just sitting here typing vague commands. So the MCP server is the central brain of the setup. It takes structured JSON from ChatGPT, which is my LLM, and then it connects to multiple data sources and systems to get the job done. My custom-built MCP server then talks to Container Lab to understand the network topology, who is connected to what. So my entire network is simulated on Container Lab. Then it queries Notobot, which is my IPAM solution to get live device and interface IP addresses. And Prometheus, I'm using it for telemetry so that MCP can monitor the interface health. GitHub is the version control system that's what I'm using. And I'm also using GitHub Actions that handles the deployment. And finally, I'm using Slack and Twilio that let the MCP send real-time alerts back to the users, and it'll all be clear once I talk about it. So the MCP doesn't just respond, it observes, it plans, and acts across the entire stack. So yeah, this isn't just a diagram. This is a live ecosystem where LLM driven intent flows through tools, metadata, and automation pipelines to make real changes in real networks. So it is modular, it is agentic, and built for scale. All right. So let's take an example of the workflow of how configuration works via MCP. So on the right side, as you can see here, there is a network diagram that I simulated in Container Lab, and it is basically in a YAML format. So if you see this Container Lab topology, it's a very simple topology. There is a switch that connects to 5 routers, and I have a network management and automation system which hosts the MCP server, the IPAM solution, Autobot, and multiple other, and my script on that system. Okay, so here is what happens when I try to configure something on these routers. So first, there is a user intent defined on the LLM, which is ChatGPT in this case. And it's going to say something like, configure OSPF on R1's interface connecting to S1 in area 0. Now, the LLM parses that input. Now, how does it parse that input? So if you see the statement here, it says configure OSPF on R1's interface connecting to S1, which is this one. It doesn't really know what interface it is actually talking about. So first, it sends a request, a JSON request to the MCP server saying, I need the interface connecting from R1 to S1. MCP then extracts that topology information from the YAML file, the container lab YAML file, and the interface names, and sends it to the LLM, which is ChatGPT. Now, the LLM knows that R1 connects to S1 on Ethernet 1 interface. So it knows, okay, for OSPF to work, I just need to enable OSPF on that interface. Next, it needs to know the IP address of those interfaces and the ones that need to be advertised. So what it's going to do, it's going to send another JSON request to the MCP server querying the interface IP address from Notabot. An MCP server then queries it from Notabot and gives that output to ChatGPT. Now, once it has all the information that it needs to configure OSPF, it builds a JSON file with all the configuration details and sends it to the MCP server. Now, MCP server, to avoid AI hallucinations where AI just hallucinates and creates its own configuration, even though it's incorrect. To avoid such a situation, I also have a Ginger 2 template on my NMAS. And the MCP server essentially picks up all the variables that the JSON file that the LLM sends to the MCP server. It picks up all the variables and uses the Ginger 2 template that I have for OSPF config, and it generates a configuration file for that particular router. So this gives full control to MCP server. The LLM is not exposed to any of the backend operations, except it just knows for anything I need to talk to the MCP server. So that gives full control on the MCP server to redirect requests as it is. Now, once the configuration is generated, MCP pushes that configuration to GitHub. Once it's pushed to GitHub, my CI/CD pipeline gets triggered, which is GitHub Actions, and it does sanity checks like, is the device reachable? Does the .cfg file does that exist in the first place? And a bunch of other checks. And once all of these checks are passed, it configures the device. MCP deploys the configuration to the said device. And then finally, it sends a notification on Slack that the configuration has been deployed. So this isn't just automation. This is agentic behavior. It observes, plan, act, react, repeat. The LLM doesn't just chat, it reads topology, pulls real data, and chooses the right tools. The MCP server doesn't just wait, it goes out and does things. All right, so here is the fun part. Watch as I tell the system to configure OSPF with a loopback IP across all routers, and I will walk you through every step and how it does that. All right, so this is R1, and let's see if there is OSPF configured in this. Nope. And what about R2? Okay, so it doesn't have any OSPF configuration. Let's see if it has a loopback IP address. Nope, it doesn't have a loopback IP. Does this one have a loopback IP? Nope, it does not. So let's configure loopback IP addresses and OSPF on both these routers and see how we go there. Okay, so I'm gonna quickly open ChatGPT And this is my custom GPT that I created. Let's start off by saying, give me all interface IPs for all routers, R1, R2, R3, R4, R5. Let's see what it says. So now it is talking to my MCP server. I'm using ngrok to make my MCP server publicly accessible over the internet. And now it gives me all the IP addresses of all the interfaces. And it just queried Autobot to do that. Okay, configure OSPF on R1 and R2 on Ethernet, let's say 81 interface, and in area 0, and also configure loopback 0 as 10.10.10.10/32 and 20.20.20.20/32 respectively. I will also keep my GitHub open, and we're gonna wait for, okay, this is an old action. Let's confirm. It's gonna take some time to configure it. Okay, so it says OSPF configuration was successful, and it says that it configured loopback 0 IP address and Ethernet 1 on both R1 and R2. And area 0 is where it configured it. And if you see the GitHub actions here, you'll see that all of these sanity checks were passed. And I should have gotten some message on the Slack. It says GitHub Actions push the configuration via MCP, sit back and relax. So let's just really quickly confirm that it indeed did configure it. Yep. And do we see something on our tool? Yep, I see it. And what about loopback interface? Yep, it configured it. Yep, it configured here as well. And if I do a show IP OSPF neighbor, I should be seeing 20.20.20 as the OSPF neighbor. So this is pretty cool. There are a lot of other things that it can do. I can make it before, like we asked for IP addresses, I could say something like check CPU utilization for R1 and R2. And it's saying about 64 point, around 64% of CPU is being used. And it is pretty high for a very bare topology, but the only reason that it has a lot of CPU utilization is because it's running on Container Lab and it shares the resources with my server. I could do something like bandwidth utilization for R1 Ethernet 1. And it's going to tell me the bandwidth. So it'll tell me the link speed, which is 1 Gbps, and the current usage is about 1 Mbps. And let's try to test this out real quick. So if I go to ET1 on R1, and I'm going to change this to, let's say, 100 full. And now let's say bandwidth utilization, or rather, let's ask the speed of R1 Ethernet 1, And now it's saying that the current speed is about 100 Mbps. Let's change the speed back to 1 gig and say check again. Now it says it's back up to 1 gig. So ideally, in the background, what's happening is my LLM is talking to my MCP server, and my MCP server is talking to Prometheus to gather poll real-time data from all of these devices, like link utilization and speed. Right, let's do something really cool now. I'm gonna say monitor R1 Ethernet 1 interface status. Ping me on Slack and give me a call if the interface goes down. Okay, now it says the default polling interval is 30 seconds. Let's change that to poll every 2 seconds. So this is also talking via SNMP to Prometheus, and it is constantly checking for any event on that interface. All right, monitoring is set. So I'm gonna go to Ethernet 1 and I'm gonna shut the interface. And let's see what happens. Okay, it says Ethernet 1 is down, and I'm actually getting a call. Let's pick it up and see.
You can remove critical alert. They have R1 Ethernet 1 is down. Please check.
Boom. All right. And now if I just bring the interface back up, it says Ethernet 1 on R1 is back up. This is super cool. All right, now let's stop monitoring. And by the way, I'm getting another call.
You can remove recovery notice. R1 Ethernet 1 is up now. Yeah, we is.
So I'm getting a recovery notice as well. If the Ethernet 1 comes back up or any interface comes back up, I'm also getting those calls. This is really cool for operational purposes. There are other things that I can do, something like give me the network topology diagram currently. And it's going to use Mermaid to draw the diagram for me. So if you see here, R1 connects to S1 and it's showing that all of these links connect to S1. And this is my NMAS, essentially host that connects to switch 1. I could also do something like tell me the interface connecting from R1 to SW1. And so it is actually querying container lab, the YAML file, and that's how it gets Ethernet 1. So yeah, that is my project. From natural language to live device config and real-time alerts that I just showed you, all through agentic AI. If you're building with MCP, network automation, or AI orchestration, just hit me up. I would love to nerd out with other folks working on this space. Feel free to reach me out on LinkedIn or my email address, which is also on LinkedIn. Thank you.